Good morning, students. We have already studied about the current and EMF. Okay, so now we are going to discuss Ohm's law. So, you know that to make current flow, you have to push the charges. So, more push means more charges flow. So, whenever we have a conductor, any conductor like this, if we want to make flow of charges, for example, if we have charges are present inside the conductor. So if we want to make flow of these charges, for example, positive charges, negative charges, so if you want to apply force on charges, you have to establish an electric field, E field. So electric field is responsible for the motion of charges. So whenever you apply a potential difference between the points, for example, this is point A, this is point B. So this point is higher potential point, and this is, for example, positive end, and this is negative end, and it is connected with a battery. This is positive end and this is negative end. So when you apply potential difference across the terminals, actually you create electric field between the ends of conductor. So electric field is responsible for motion of charges. So charges start moving because electric field is force per unit charges. As you increase electric field, you increase force. So you apply force on the charges. So charges start moving across the conductor because they feel force due to electric field. So we say that electric field is J current density. J is directly proportional to electric field. J is here current density. I over A means if you increase electric field, you increase J current density. So as you increase electric field, you actually increase the current. So whenever we remove proportionality sign, we give a constant. This is sigma, and a sigma is conductivity of the material. I hope you are getting. So there is the conductivity, and the conductivity depends on material. It is property of the material. Property of the material. So, for example, we say that for metals, its value is far more higher than insulators. For conductors, it is not infinity, but we usually say that for metals, metals means conductors who conduct electricity, their conductivity is approximately equal to infinity. And for insulators, conductivity approximately equal to 0. So insulator do not conduct electricity, such as plastic or wood or glass. These are insulators. And metals such as copper, iron, so that is a microscopic form of the Ohm's law, that J is equal to sigma into E. You can also write sigma. Sigma is a conductivity that is reciprocal of 1 over rho. Rho is a resistivity. Rho is resistivity. So good conductors have resistivity approximately 0, and for good conductors are perfect conductors, and for perfect insulators rho is infinity. And that was microscopic form of the Ohm's law, but you can also write that law in terms of general form. So if you want to write that law in general form, then we know that J is equal to sigma into E, and a J is current over area, and sigma is 1 over E, and we know that also E is equal to potential difference over length of the conductor. Usually we write E is V over X. So we can write I equal to A V over rho into L. So this quantity that depends on dimensions of the conductor and property of the material, that is equal to 1 over r equal to a l into rho, or you can write r is equal to l rho over a. So that is resistance of the material, or you can write I is equal to v over r. That is more general form of the Ohm's law.